My name's Fitzgerald. I'm from a company called Petrik Pacific. We distribute the range of Petrik biological products within Australia. I've been doing this since 2002. I became involved in biological farming through disease control in banana plants actually, and we followed that stream through until we encountered the Petrik people and we picked up their product range. We've had a lot of success in the banana industry, and that's still our major base. We operate on approximately 40% of that. I have 4 agronomists that work for me up there, but we've got centres in other areas, and our product use is growing through our pasture in particular, but certainly in broadacre as well. There are certain conditions that are required for successful use of this product, like stewardship's a really important part of it. And that's what I like about the Petrik system, is what attracted me to it in the first place, is they also look at the soil chemistry. You know, if you've got a limitation in soil chemistry, not so much nitrogen and phosphorus, but in terms of trace elements and pH and calcium, magnesium, and in some cases potassium, that needs to be addressed for any system to function correctly. And so we've had places where we couldn't convince people to adjust their soil chemistry, and we maybe had some results that weren't so positive there. But everywhere where we've had control of the system, where we've been able to influence the grower to address the elements that needed addressing, as well as implementing our product range, along with fresh organic matter, right, which is basically easily digestible starter material for the microbes to start the humus creation process. And once that starts, it continues itself and it develops through the soil profile. Like, the core of the system is humus creation, and that is so important. Like, humus is the life force of the soil. It's the difference between soil and ground up rock, and it's homes for microbes. It gives you soil structure, which means you get better rooting depth, you get better water infiltration. Your native microbes can then carry out the task that they were supposed to do without the limitations that are principally structural. In so many cases, it's structural limitations to biological activity. And that's how the system works, but you have to have the right tools in place for the microbes to operate. Just throwing the microbes at the soil and hoping for the best is probably not going to work in most cases. The problem in conventional agriculture, as I see it, is agronomists are pretty much sales driven in so many cases and they're under a lot of pressure. That the system pretty much forces them to drop something off the truck and keep going. And I've seen in so many cases that people had the answers to their problems on their existing soil tests, to some of their limitations that hadn't been addressed. And that's really frustrating, because it's so annoying to see someone not realising the potential they should be from something that they had the answer to in front of them the whole time, but just no one had pointed it out to them. But then on the other hand, like there are some limitations in conventional agriculture that can't be addressed by straight chemistry, and that's where Petrik comes in. I mean, agriculture utilises nature. It utilises the natural resource of our planet, but it's not actually natural. Like, farming's not natural. And in a natural system, you've got lots of different root exudates from lots of different plants, supporting a wide spectrum of microbes, which is how your soil biology develops. And we come along and we cultivate it and we plant crops, or we put fences up and we plant pasture species, and we change that, right? So the root exudates are changed. We've got animals impacting it. We've got tractors compacting it. And so some in soil biology degrades, and it's when you lose your humifying biology that your soil really starts to slow down. Now, everybody's talking about organic carbon loss from soils, and yes, that's a bad thing, and we've got to replace it, but we didn't just lose carbon. We lost humus, and putting carbon back is not putting humus back. You have to address the problem, and that's the big difference with our biological product range, is that we have the biology that can initiate the humus creation process. And once you do that, you can restore your soil to where its full potential. We use much lower rates of manure than are probably considered normal in agronomy. We're down to 1 tonne of the hectare in a lot of the pasture systems, and 2 tonne of the hectare in cropping is very common for us now. But where we have that resource available, and we've yield mapped biology application across that with the manure on the whole paddock and the microbes in strips, we've yield mapped 31% increases in sorghum, in grain sorghum, a 25% increase in durum wheat, and we've measured 27% increase in weight gains in Angus steers. There was average 300 grams a beast a day advantage from the application of the microbe being the only difference in the two treatments. We're in the middle of a corn crop in Victoria, and it looks like we're going to double the yield there. It's much cheaper than conventional options. When you have the soil active and the soil microbes doing the jobs that they should be doing, you're going to release phosphorus that's in the soil. Like the conventional approach to phosphorus application is close to ridiculous. There's growers in Tasmania using up to 400 kilograms of phosphorus, and they put it on in a band that wide in order to supply phosphorus to a crop that they know is going to remove 30. And they come back the following year and they do it again. Like they put it on knowing it's going to be tied up, but their answer to that is to put more on. And it's commonly accepted we get to use 10 to 15% of the phosphorus we're applying. We can use the phosphorus that's available in the soil, we can use the phosphorus that you've put on that's already been tied up, because the biology has the ability to break calcium phosphorus bonds, release that phosphorus, make it plant available again. And in a perfect system, when your soil biology is operating to its potential, the nutrient supply to the plant becomes driven by the plant. Plant roots will produce exudates to support phosphorus releasing biology in the absence of phosphorus, and in the absence of high nitrogen rates, they'll produce exudates to support nitrogen fixing microbes. Even non-leguminous plants, so they have a semi-symbiotic relationship with these microbes. It's still symbiotic, they just don't form a nodule. So it's nitrogen and phosphorus are the two elements that we can pull right back, and while we're doing that, improve yield. Now, in terms of chemistry, if you need calcium, magnesium, potassium, copper, zinc, manganese, boron, cobalt, molybdenum, pretty much put them on. It's business as usual, and probably because we're paying attention to it, we're probably using more of those elements than conventional agriculture. Because the biological release mechanism for those are very slow. But nitrogen is really, really strongly related to biological cycle, and phosphorus in particular.